see the potentiometer. Now what is the purpose of this potentiometer? It is used to find out the unknown EMF of a cell, and it is the most accurate method to find out the unknown EMF of a cell by using this method. There are other methods also available, but it gives most accurate reading compared to others. Now let us see how the way it is. You need to take two cells, out of which one will be unknown and the other will be known. The two types of cell, usually one will be Leclanche cell and the other will be your Daniell cell. Both will be coming under your primary cell, Leclanche and Daniell cell. Now what you are going to do, the difference between the meter bridge and potentiometer is nothing but there you are taking your total length of 1 meter. Here you are taking the total length of 10 meter. The type of wire is same, either manganese or Constantan, but the length is here 10 meter. Each one length will be 1 meter and they are connecting like this fashion, so that it will be coming in total 10 meter in length. Now let us see the application of potentiometer. It is used to find the unknown EMF of a cell. Second, it is used to find the internal resistance of a cell. For these two purposes, your potentiometer is used. Now let us see the first one where you are measuring the unknown EMF. First one to measure the unknown EMF. Same way, what you need to do? See here, there is a two-way switch. You can give this name as 1, this as 2. Now, initially, let your switch be connected to position 1. So, when your switch connected to position 1, what will happen? Now, E1 will be active, E2 will be inactive or not active. At that time, just adjust this jockey. So, at some particular balancing length L1, your galvanometer shows a 0 deflection. That is nothing but the balancing length. So, what you will write? Your E1 proportional to L1. Now, what is E1 equal to? Substitute your proportionality constant. That is KL1 over. Now, next what you need to do? Change your switch to position 2. Now, change your switch to position 2. When you change your switch to position 2, what will happen? Again, same way, adjust the jockey. Some other point, it will show the balancing length where galvanometer shows a 0 deflection. So, let that balancing length be L2. This is when your E2 is active. E1 is not active. So, what you will write? E2 proportional to L2 and E2 equal to KL2. Let this be your equation 1. This be your equation 2. Simple. Now, your target is to find the unknown EMF of a cell. So, what you will write? Divide equation 1 by equation 2. That is nothing but E1 by E2 equal to L1 by L2 over. So, simple or not? So, what is the principle of potentiometer? The EMF of a cell is proportional to balancing length. Okay, that is nothing but called as potential gradient. That is change in potential with respect to change in length. Now, come to the second, where you are measuring internal resistance, small r. When you are considering to find the internal resistance of a cell, what you need to do? Just remove one of the cell. Let this cell you are removing. This is alone one cell. Okay. So, now in such a case, the second cell where you are removing, you just connect a resistor. Clear? Now, same way, there is a Dpdd switch. It is called as a double pole, double throw switch. So, imagine initially your switch is connected to position 1. So, for this what you will write? Your E is proportional to L1. Same way, you will adjust the jockey. It will give the balancing length. What is that balancing length? Let it be L1. So, E proportional to L1. E equal to KL1. Now, second case what you need to do? You will just connect it to here. So, when you connect it to here, what will happen? There will be certain drop across this resistor. So, what is the drop? Let that drop be V. So, V proportional to L2. So, when your P proportional to L2, you can write V equal to K2. Divide equation 1 by 2. This will be 1. Let this be 2. What you will write? E by V equal to L1 by L2. Your first part over. Now let us see the second part. I already told you what is your V. V is nothing but E minus IR. This is your cell expression for terminal voltage is nothing but EMF minus the internal drop. This is. So can I write it as E equal to, this is nothing but V plus IR. What is V? V equal to IR. The drop across the external resistance. So IR plus small I. So take I common, what you will get? R plus R. So now can I write E by V equal to, what is E we got? I whole into R plus R. Divided by, what is B? It is simple IR. So I get cancelled. What you will get? R plus R by R. Fine. So now substitute it here. It is also E by V. This is also E by V. So can we write it as R plus R by R equal to L1 by L2? This part can I write it as R by R plus 1 equal to L1 by L2? Now just take it to right side. R by R equal to L1 by L2 minus 1. Our target is to find internal resistance. So what is my internal resistance? It is R whole into L1 by L2 minus 1. So simple. Just a simplification. If you know this thing, V equal to E minus IR, another is V equal to IR. These two you are just substituting. Finally, this is for your find the unknown EMF cell. This is to find the internal resistance of the cell. Just take your rough note and practice it. It will be as simple as that. You'll start enjoying. Okay students, take care. Bye bye.